Welcome back, guys. Here we will try to understand how internally data store happens and how this hash code and equals method will help us. So now focus here, whatever I told, modulus of 15, why I am doing that, you will understand now. So basically what happens is whenever you try to store data into a map, okay, whenever any data, either this primitive type or custom object type, any data when you try to store, what happens behind the scene is now let me, yeah, 75% would be great. Yeah, so by default if you look at what happens is, first focus on this is very important, we need to understand this diagram. Okay, one array will get created, we call it as a bucket. One bucket will get created of size 16, and as I was mentioning, size will start from 0, it will start from 0 till 15. So one bucket will get created. Now we can store all the data in these buckets, right? Which means whatever hash code is coming, we have to do a modulus by 15, then only we can incorporate in this bucket. If you will not do modulus by 15, their index value will not come between 0 to 15. That is the usual practice. So let's say you need to fit the data between 0 to 20. So whatever number you have, if you will do a modulus of 20, it will give you some data between 0 to 20. Index will be somewhere 0 to 20. That's how it is. Okay, that is the reason I was calculating here modulus. So just understand first what happens is, whenever you create the object of any hash map or hash set, first one bucket will get created with size 16. Okay, just one bucket, nothing else will be there. Forget about this diagram. Okay, do not focus on this, just one bucket, 0 to 15. Now what I'm trying to do here is, I am doing a modulus of 15 so that whatever index will come, whatever, if you look at now you can understand, whatever index will come, it will come between 0 to 15, right? It will be between 0 to 15, right? So now focus on this data. So for every data when we were inserting to the map, it was generating some hash code. If you remember now, these are the hash codes, right? These are the hash codes and these were the index for the hash code. Now everything I have captured in the notes so that we can see here. So if you look at here now, these are the object Aman, Sunny, 2 times Ritesh, Ram and 2 times test we were inserting, right? These are the objects. Okay, these are the objects we have inserted and this was the output. So for key is equal to Aman, value was 2, hash code was this. So when this hash code, when you do a modulus of 15, you will get 4. You can try in the calculator. Okay, for key is equal to Ritesh. So how data insertions happens? First time what happened, you got this key is equal to Aman, value is equal to 2, hash code is equal to this and index is equal to 4. So what you will do, once you will get this, what you will do, it will come here, it will check for the index 4. Okay, this is the index 4. Does this index 4 has any data? No, there is no data. In beginning there will not be any data, as I told, right? It will be plain array list like this. No data, nothing, just indexing will be there. Okay, just indexing will be there, but there will be no data. It will be like this, right? So 4 has no data. So what will happen on this 4, one node will get created. Whatever you are seeing, that one node will get created, because map internally uses linked list. Internally it uses linked list to store the data. So what happens, one node will get created, and what was the key? So key was Aman. See, the key was Aman basically. So basically if you ask me, key was not Aman, by the way. Okay, just for your convenience I have written here, key was never Aman. The key was this guy. This guy was the key. So basically it was object. Okay, it was the object, so I should not do here key. Okay, now if I run that, you probably understand. See, where is the output? Yeah, so okay, since I'm overriding the toString method, let me do not override the toString method. Key is nothing but some address you will get, because it's an object, right? So you will get an address. See, key is like this, you will get like this was the key actually. This is nothing but your object address, right? This is nothing but your all object address. So if you look at here, all the object address are different, all the objects address are different here. Okay, so since I did key dot data, that I should not have done that, just for convenience I have done that. So again do that key dot data, so that by looking the reference you will not understand. But when I do key dot data, so every key has a data, right? So then you can make sense, right? You can correlate like how it works, but actually it was object, right? Now focus here on fourth index. One node will get created, and this is the hash code on the fourth index. This is the hash code, right? The hash code is nothing but 99554 ending with, right? So this hash code will come here, this hash code will be here, and this hash code is nothing but the address of the node. So this complete node, whatever node you are seeing, that this hash code is the address. By through this address you can identify this node. So one node will get placed here. Aman is the key, value is equal to 2, and the next is pointing to null. So one node will get generated here on the fourth index. Now if you look at on index 8, so again now key is equal to Ritesh, value is equal to 50, index is equal to 8, and this is the hash code. Okay, so again for this hash code, when you do modulus of 15, okay, when you do modulus of 15, you will get 8, you will get here 8, right? So go to now index 8. So if you go to index 8, again here it was empty earlier, so this hash code will come here 9733, that's what we have here, right? So it is 9 ending with 9733. So again one node will get created, and this node will get created. So and the data is equal to Ritesh and Ram. So first I have inserted Ram, it's okay, because when I was designing this diagram I forgot the which came first. So just you can ignore this for timing, just try to understand the concept. So let's say on index 8, just assume that on index 8 one object came, okay, and there is some key value. So you can see that one node will get inserted here, Ram. This has a key, this is the value, and this is the address for this node. The same address will go to the index 8, it will go to the index 8. Now in beginning this will be pointing to null, like how it is pointing to 4 in beginning, right? Then again what will happen, again on index 2, so again what happened, again one more hash code came, okay, and even for this hash code when you do modulus of 15, it came same index, which means there is a collision now. So on the same index there is one more key now, one more key will come on the same index. Even in the output you can see that. So let me run that. Okay, you can see that on this same key, okay, on the same index there is two data, Ritesh and Ram. Okay, on the same index Ritesh and Ram is coming, right? Though the hash code is different, but the index is same. So what will happen now, when second time you will get the same index. So actually how this will work is, when the second time, the moment the data will come, this let's say Ritesh will come, okay, second time the Ritesh will come. So what will happen, first it will come to this bucket, it will check on index 8 there is any object. Yes, there is an object, okay, there is already one object which is lying, Ram is already there, okay. So when there is already one object, it will check for the hash code. What is the hash code of this object? So the hash code is 9733, right? The hash code is 9733. What is this hash code now? The hash code is now, let's say 3938. Okay, assume that it's a different hash code. So first there should be Ritesh, but I have added this Ram. So assume that like 3938. Okay. So what, since the hash code is different, your conditions will break. The put method conditions which I have told you here, right? Hash code should be same. Then only it will override. So when you go to the put method, when you go to the put value, here you can see that your hash code should be same to override and your object should be same, then only it will override. So this condition is breaking here. Now these conditions will not fulfill. So what it will do, it will try to insert a new record. So after this node, one node will get inserted, one more node will get inserted, and this will not be a test actually. So what was the first was Ritesh and then Ram, right? So let me do one thing. Let me, instead of Ram, this was Ritesh, and this is not test. Okay, just I have designed a diagram. This is Ram. So for your understanding will not anyways break. Okay, this is Ram. So now one node will get inserted. For this value is equal to 7. Now what will happen? And there is one more node get inserted. Now earlier this Ritesh was pointing to Ritesh, next was pointing to null, linked list concept, which I have told you when I was talking about the linked list. Okay, so now what will happen? Now this guy, the first node will point to the second node, so the link will get created, and whatever node address you have here, this is nothing but the address of the node. Now this address will be here, this address will come here, right? So that is the reason this index 8 has the address of first node, and the first node has the address of second node. So the linking will happen like this, right? This index has the address of first node has the address of second node, and now this will point to the end. So this will, when this will happen, whenever there is a collision, whenever you have two objects which has the same index, this collision will happen. Okay, now come back, we have stored this. Then again index 2, there is a Ritesh and value is equal to 2462. So this is simple one. You have only one index 2 has only one record, 2426. So one node will get created. This node address is 2426. This is the Ritesh is the key, value is equal to 5, and this is pointing to null because there is only one node. Now what will happen is, here on index 11 you have one record, there is no difference. Index 5 you have Sunny and hash code is 3135. So index 5 Sunny will get created. You can see that Sunny node will get created. Sunny value is equal to 7 and the hash code is 3135. The same hash code will be here. So why we are keeping the hash code here also? So that this index will have the reference of the node. Okay, right? These indexes should have the reference of the node. So tomorrow if you want to access, you can access these nodes through the reference of the index. Okay, through the reference of the index. So this is while storing. While getting also we do the similar process that I will talk later. This is while storing. Now again if you go back, there is some at index 0 there is some test which hash code is this. So again on 0 also one node will get created. So that's how internally data stores happens. Okay, when hash codes are different, one different, you can focus here, mainly you can focus here. When hash code is different, one new node will get created. But when the hash code is same and the object is also same, the same node will get replaced, which I have already shown you in the program also, right? So this is the internal implementations of the HashMap. You have a bucket, the bucket will hold your linked list reference, your bucket will hold your linked list object, all the linked list object, and whenever there is a collision, whenever one index has a multiple data, and if the both object has a different hash code, then that's how the node will get added. One node, two node, three node, four node will get added. So this is the internal implementations of the HashMap. Now how this will get avoided by overriding the hash code and equals method, because the thing is, if you look at one thing what we are doing, that see, Ritesh test you have here also, Ritesh you have here also, Ritesh you have here also. Similarly you had test also. If you look at here, there was test here and there was test here, right? Two tests. So these are all duplicate data actually, because as a programmer, though you are giving me different object but the object data has same, then I should not keep two record, I should keep only one record. Okay, If there is only change in the object, then only I should consider that object as a different object, otherwise I should not consider it. So that's how internally guys it works, and that's how when the hash code, and that's how the data will get stored based on the hash code. And when the hash code is different, that's how the different node will get created in case of collision. In next video we will talk about some more concept of this hashing. Thank you guys, thank you for watching this.